There is something peculiar about the oxygen in the upper atmosphere of Mars's Gale crater. As the seasons change, there is a rapid fluctuation in the concentration of oxygen. The mysterious circulation of oxygen cannot be explained by any known chemical substance we are familiar with. The Gale crater formed 3.5 to 3.8 billion years ago due to a meteor impact, measuring 154 kilometers in diameter. NASA's Curiosity rover landed at Mount Sharp in the center of the Gale crater in 2012 and has conducted studies since. Over the past 3 years, the rover has utilized its onboard portable analyzer to conduct analyses of the atmosphere above the crater. The analyzer confirmed that Mars' atmosphere is composed of 95% carbon dioxide, with the remaining 5% consisting of a combination of nitrogen, oxygen, argon, and carbon monoxide. The analyzer found that in Martian winters, polar CO2 freezing leads to a drop in overall atmospheric pressure. Conversely, during the Martian summer, as temperatures rise, carbon dioxide evaporates, leading to a resurgence in atmospheric pressure. Additionally, argon and nitrogen levels rise or fall predictably in the atmosphere depending on the amount of carbon dioxide. However, the results for oxygen were entirely different, leaving scientists perplexed and soon immersed in confusion. The oxygen levels during spring and summer rose to levels more than 30% higher than the baseline, only to drop significantly lower than expected during the winter. Scientists at NASA's Goddard Space Flight Center are currently grappling with the challenge of explaining this mystery. Initially, scientists are considering that the irregular fluctuations in oxygen concentration during each season may not be directly related to atmospheric dynamics. Moreover, physical processes such as molecular breakdown seem insufficient to explain these phenomena. In conclusion, scientists suggest unknown substances or absorption sources may be at play in explaining this phenomenon. This puzzle is also connected to the issue of irregular methane levels within the crater. The analyzer found that, in previous analyses, unidentified methane increased by approximately 60% during the summer, only to irregularly plummet regardless of the season. Sushil Atreya, a climate and space science engineering professor at the University of Michigan, points to a tantalizing link between methane and oxygen. The professor states, "There is something in the relationship between these two, but what that something is, we don't know." Oxygen and methane can be produced through both biological and geological processes. However, scientists currently lack understanding of any process capable of excessively generating these gases. While it may disappoint conspiracy theorists, scientists generally lean towards the possibility that excess oxygen and methane are more likely results of geological processes. The research team currently estimates that the most probable source of this excess oxygen is the soil on Mars. However, even if that's the case, we have no idea what exactly in the Martian soil could be releasing such significant amounts of oxygen into the atmosphere.